Suppose here we have a system that may infinitely wide, and we split this system by this blue line. Here we set below medium as well as blue, and we split again by this red dot dot dot. And suppose that from this point there is a beam of light that travel by this path at medium 1 and this path at medium 2. Because of this bend, we characterize this angle as theta 1 and this angle as theta 2. This phenomenon in daily life we know as refraction of light. Next, we need to know the relation between these two theta. We set this vertical length part as A and this part as P. Here, we have the total horizontal length as L, which in this scenario, L is the total length from beginning to the end, and so on for A plus P that is beginning to the end. We know that in Maxwell's electrodynamics theory, the medium characteristic can be determined by propagation of electromagnetic field, or for simplicity, in this case, the propagation is about speed of light of each medium. So that's why we separate V1 and V2. So by this scenario, the total time for the light to travel between beginning and ending is about this equality, which x here is about distance along L that parameterize the position of light beam in the different medium, which I mean in this scenario, x is about this from the beginning. And by using Fermat principle that light travel to path that takes the least time, so then we need this differentiation condition, which after some effort, we will have this, and this part is sin theta 1 and this part is minus sin theta 2. So that's why we will have this equation. And for last but not least, let V1 is equals to this, which N1 here is about refractive index. So after plugging this equation to the equation before, we will have the result as this, which these two results we know in today as Snell's law of refraction.